welcome back again. So this time what we're going to be playing with is touches and gesture recognizers. We're going to be building off the moving example smile that we did last time. So last time what we did is we did the core graphics work of the moving smiles example. So go ahead and bring up that code. Should hopefully have a working copy of it. What it should do is you should be able to double click and it will draw a smile. This should work on the iPad or the iPhone if you've stayed fully up to date. Another thing I want to point out is that if you click on top of a smile, you can see it'll make another one basically right on top of the old one. That's going to be important for something we're going to do here in a second. So that's what this thing should do already. Let's see what we can add to it with gesture recognizers. So the first thing I want to say is what are some of the advantages of core graphics? Some of the advantages are that the drawings that you use vector graphics, which is nice because you can zoom in on them and it'll maintain a perfect pixel quality. They're not confined to the zoom. It's also really easy to do interaction with core graphics instead of an image, right? So for example, it's really easy to do things like if we wanted to change the shape of the mouth, we could do that with core graphics, where if it was an image, it'd be really hard to do. What we're going to do is if you wanted to change eye color, if it was an image, that'd be hard to do, but since it's a core graphics, it's easy. So we're going to do some of these things just to kind of show off why core graphics can sometimes be better than just creating a bunch of UI image views. So we're going to go through these kind of one at a time. What I'm going to do is I'm going to copy paste from the slide slot. If you'd like to also copy paste from the slides, just go to the course website, click on the link for this video, and then you too can copy paste to make yourself super speedy. Cool. So if I grab that, which I don't think I did yet, copy. So what I want to do is into the smileface.m file. I want to stick in touch event handling. To keep myself organized, I always like to throw in these pound pragma labels. And the only reason they're nice is now you can click on it and you can see real quickly it puts in this dividing bar. So all I've done is I've just put in these blank methods, which you might think, well, what's that going to do? They're all blank. It actually does something very important to the responder chain, and that is if I double click on top of a smile now, it will not make a new smile. You see I have to just barely go outside the smile, and then it'll do it. But just barely inside a smile will do nothing. Barely outside will cause a new smile to form. The reason this is important is because this defines how the responder chain works. The responder chain works by going view by view and saying, do you respond to touches? Do you respond to touches? And before, a smile didn't respond, so it went on through. But now that it does respond, it picks it off from the responder event. So just having these in here does do something. So I just kind of want to make that point. Now let's make it do something useful. So as a kind of a first test, what we're going to do is we're going to look for a double click again. So we're going to grab any touch, and a touch has a thing called a tap count. We're going to look to see if the tap count is 2. And if the tap count is 2, we're going to change the eye color, and then we're going to tell the view that it needs to redisplay. So it needs to recall the drawRect function. You don't call drawRect directly. You just say needs display. And the only thing that's really going to change is it's going to have a different eye color at this point. Also, just to kind of mention it, a tap count currently is only supported for when there's only a single view. So if somebody does double tap with 2 fingers, this won't work, but that's fine with us. So if you run it now, what should happen is if you double click outside of a smile, it'll add a new one. But if you double click inside of a smile, it should change the eye color. So you can see that if I double click smiles now, it'll change the eye color. So we're picking off the touch events, and we're actually doing something with them, which is kind of neat. Cool, so that's a great start. The next thing that we want to add, we'll just kind of add our user interaction capabilities. we want to be able to move smiles around. So to do this, inside Touch is Moved, go ahead and add some code to move a smile. We grab any touch, just like we've done many times. We get the location of the touch in the super view, so not in the location of my own view, but in the location in the super view. You can get the super view just by saying self.superview. Anytime a view is added to another view, there's automatically a link to the super view. And then we're going to set the center of this view, the smiley face, to that location in super view. 3 simple lines of code actually adds a lot of user interaction capabilities. Now you can drag smiles around and they will move to wherever you want them to go, which is kind of neat. So with 3 lines of code, we've added a lot to our program. And you can move these things around to your heart's content. You can also double click on them and change the eye color as much as you like until you get them all the color you want. Cool, so these additions are kind of based on things you already know about touches. Let's go ahead and explore some of the new stuff. So some of the new stuff is the UI gesture recognizer. Anytime I want to see something new, I can usually look it up in help and get a little bit of information. So if you type in UI gesture recognizer into help, it'll bring up the class reference document. If you read this, you can see that this class, UI gesture recognizer, is actually an abstract base class, so you shouldn't instantiate it directly. I think officially in Objective-C there's no such thing as an abstract class, but you can still have the concept, right? So you shouldn't ever create one of these directly. What you should create is you should create one of these concrete subclasses which will detect a certain type of gesture. The ones that we're going to use is we're going to use tap, pinch, rotation, and long press. I'm sure you can figure out the others on your own. A couple of the capabilities that we're going to need to do is we're going to need to be able to initialize them. When you initialize it, you have to say what function it should call when it detects it. And then there's a couple other things that we'll do as well, but we'll get to that when we see it in action. So let's go ahead and see these things in action. The one that we're going to do first is a pinch gesture recognizer. So let's go ahead and copy some code over and then we'll talk about it. So into the init with frame, we make an eye color, and we also set the background to clear, and then we're going to add a gesture recognizer. The way the code works for a gesture recognizer, I'll go ahead and break it up onto 2 lines like this, is the first thing that you want to do is you want to create one. So you say what type it is. So this is a pinch. We're going to alloc it. And then we're going to say init with target. And then action. So we say what object we're going to call the function on, and then what selector we're going to call. So we're going to call ourselves, and we're going to have to write a function called handle pinch. You can see by the colon that handle pinch is going to receive something. So we've still got to write that function, but that's okay. The next step we have to do is we have to associate this gesture recognizer with a certain view. We're going to add it to this view self. So whichever smiley face it's on, it's going to be associated with that smiley face. Once you add it to a view, it actually increases the retain count so we can release it here, which is a safe thing. So let's go write that function, handle pinch. And so what handle pinch is going to look like overall, we'll just go ahead and put our gesture recognizers down here. So I'm just going to go ahead and try to keep it organized. UI gesture recognizer callbacks. So the first thing that we're going to do with a gesture recognizer is we're just going to print out a message that says that it's detected. That way we'll know if it's working or not. Then the next thing that I thought I'd mention real quick about a gesture is some gestures are discrete, meaning it just says it happened or not. Like a swipe is discrete. It just says, yes, I got a swipe, or there is no swipe. However, some of them are continuous. Pinch is continuous. So pinch has a state that is either began, changed, ended, or there's a few more, but these are the ones we actually care about. Began, changed, and ended. So when it first sees it, as it's moving, and then when it's done. So let's go ahead and run this, and let's see if we can cause this pinch gesture to occur. For some reason, for me, it has to all fit on the screen for me to be able to do a two-finger. The way you do a two-finger is you hold down the Option key, and you'll see two little circles pop up. And if you click down with your mouse and pull directly like away, that should have been identified as a pinch. So you can see that it detected a whole bunch of pinches in there. So we've got a whole bunch of pinches. So it's getting called. That was the first step. That's good. The next thing we want to do is we want to try to do something useful. You can see that what got passed in was a pointer to the pinch gesture. This is actually really important because we're going to get information from that pinch gesture. A pinch gesture can do anything a gesture recognizer can do, plus it's got a scale property and a velocity. I'm not worried about velocity, but I do want the scale value. So this tells you the relative distance between the points on the screen. So what we're going to do is we're going to use that scale to make changes to our bounds. So I'm going to replace my old function with this slightly modified one. What I'm going to do in here is I've got a couple variables called initial bounds and new bounds. So I'm going to change the bounds. And what I choose to do is I choose to go ahead and store off the initial bounds. And then I chose to go ahead and let it fall through here. I chose to let it intentionally fall through the case statement, and notice how there's no break. And that's just because when you get the message for state began, it actually does already have a scale even with that initial one. So when it first begins, I go ahead and store off what the bounds were before I started scaling this thing. And then what I choose to do is I choose to make the bounds bigger, so I make the width and the height bigger, depending on what the scale value is of the pinch gesture. So that'll make them bigger. I chose to go ahead and change the bounds. I could have changed the scale value of the transform, but by changing the bounds, I think it helped me keep that vector graphics quality that I wanted. And then in order to actually make use of it, I need to call set needs display, so that it'll actually make use of the vector graphics benefit that we get. So you can see we store it off initially, and then we make it bigger based on the scale. So let's go ahead and see this in action. So if I double click to make a smile, and then I want to pinch it, you'll notice that you can only pinch things in the middle of the screen. So I put it in the center of the screen for a reason. You can see that now I can go ahead and make this thing much larger, which is kind of neat. I could also choose to make it very, very small if I wanted. So we've got the ability to zoom in on it. Probably the most important thing is you can see that the pixel quality with vector graphics is so nice. This line is just as sharp. This gradient just keeps getting better and better. Whereas if it was an image, it would start to get pixelated as you zoomed in, right? Whereas that doesn't happen with vector graphics. So that is pinch, which is great. One thing you will notice about pinch that is annoying is if I start to pinch them apart, so I'm going to click and I'm going to barely move here, you see that it jumped down, and that's because the move made it jump down. If you want to make that move not happen real quick, it's fairly easy. you just have to add a check in the double in the move area. Check to make sure that there's only one finger on the screen. So what this will do is this actually touches, gives you a set of all touches that are in the phase touches moved. If you want to make sure that just no other fingers are on the screen, instead of using touches, you can say from the event, give me all touches. That just gives you everything, not just the ones that are in this phase. So give me all touches. If the count of all the touches is equal to 1, then move it. But if that's not the case, then don't move it. So if you really hated that little hiccup about how it moved it to start with, so now you can see if it's, that's a little too big. So now you can see if it's up here and I want to go ahead and pinch it apart. If I start moving just a little bit, you can see it stays where it's at. That's just a little personal preference thing. So the next thing I want to do is I want to be able to rotate this guy. It'll help us learn about another gesture recognizer. It'll help us learn about the rotation gesture recognizer. The rotation gesture recognizer has a rotation and velocity, so it's going to work a lot like scale did, right? So it's got a rotation here. So we're going to follow the same steps that we did before. It would be great if you could try to do some of this on your own. So if you want to pause it, see if you can figure out what adding the gesture recognizer would look like. It's 3 lines of code and it's very similar to what we did before. See if you can pause the video and see if you can give that part a go. Alright, I realize most people don't, but I try. So if we wanted to add a gesture recognizer, it has the same look and feel as the other one. We create it. And we say instantly like what function it's going to call. So it's going to call the function handle rotate. That's what I chose to call it. You could probably name it something better. Handle rotate is good enough. We link the gesture recognizer to a view. Doesn't do much good if it's not linked to a view. And then to take care of memory management, we go ahead and release it because the view holds onto it for us. Next, we need to write the handle rotate function. Handle rotate works quite a bit like the scale version. It is a continuous gesture, so it's got a began, a changed, and an ended. And so here you can see that I'm checking just to make sure that it works. The way that you can do a rotate gesture is you can hold down Option, and instead of moving up and down when you first start, click and then move like left or right. So here I moved to the right a little bit. That should have called a bunch of rotates, and it did. So you can see that rather magically the system figures out the gesture and then it calls you when it thinks it sees it. Your job is to do something. So the job that we're going to do is we're going to rotate the view. So instead of just printing out a message, let's go ahead and actually do some rotation. So I do the same thing I did before. I'm going to store off the initial rotation transform. So instead of a rect, it's a CG affine transform. So I store it off in began, and then I go ahead and let it fall through to go ahead and update it even for the began. And I change the initial transform matrix, and I rotate it by the amount rotation. They are nice to you, and rotation is already in radians, so you don't have to worry about that. So it is already in radians, so you can just go ahead and send it right into the CG affine transform rotate function. We talked about this last or a few examples ago, so you should be familiar with this function. And if we run it now, you can see that we can pinch to make it bigger, and then we can also rotate this thing to make it at some funky angle. You will notice that the way gesture recognizers work is you can't do both together. Once it locks in on a pinch, it is locked in on a pinch. The only way to do a rotate after it's locked in on a pinch is to let off. That finishes the gesture. and then you can come back in and you can make it a new gesture next time. I think that there are fancy things you could do in the code to fix that, but we're not going to do them. So you can make as many smiles as you want. So long as they're in the very center of the screen, you could rotate them and scale them. Obviously, on a real device, you wouldn't be limited to this middle of the screen situation. That's just kind of a feature of the simulator, that you have to be in the middle of the screen. Cool. So these are the primary things that I wanted to show you. But now let's just have a little fun and let's show you a few other things as well. So we've talked about a couple of the different gesture recognizers. The next one we're going to show you is long press. Long press is a very simple gesture recognizer. It works really pretty straightforward. You could set some things about the requirements. We're just going to use the defaults. And what we're going to do is we're going to make a face angry. If you click and just hold down on it, we're going to make that face be angry. So the first thing we need to do is just like before. It's almost not worth talking about it. It's so similar to what it was before. We're going to add a long press gesture recognizer. So the only thing that changed is the object instance type. So now it's a long press. It's going to call a function called handle long press. You probably saw that one coming as well. And what this function is going to do is it's going to set an IVAR called angry. When the state begins, we're going to say angry is yes, and then when it ends, we're going to say angry is no. Another thing I added for fun, just because I wanted to show it to you and I didn't know where else to include it, is you can also change the order of the views of all the different subviews. And the way this works, if you say self.superview, so that's the super view that we're in, bring subview to front self. So that'll bring this smiley face to the front. So it'll make it angry and it'll bring it to the front. So we said, let's use this IVAR, but we haven't actually made it yet. So let's just go ahead and do exactly what we did before. Let's go ahead and use the underscore convention. So we've got a bool angry. Note it is not an object, so there's no star. And then just like we did before, I'm going to go ahead and put the property in side and instance because that's considered good form to make it private instead of public. And then the property will not have an underscore. And then another thing you can do is for most bools, they change the getter to be is something. So is angry would be the getter. I personally don't like that style, but it is kind of the standard expectation. So I'll do it as well. And then we can go ahead and synthesize the angry property using the underscore angry IVAR. No memory management needs to be done because it is a bool. So you can see dialect does not need anything new. So we set this this IVAR via the property, which is all well and good. Next, we really need to do something with it. We're going to do a couple things with it. So here's information about the IVAR and property. What we're going to do with it is we're going to change the eye color to start with. So if you find inside your draw rect where we set the eye color, you can see we set it right here. What we're going to do instead of that is instead of just always making it set to the eye color, we're going to look to see if we're angry or not. And if we are angry, we're going to make them red. If we are not currently angry, then we'll do just what we did before. So instead of always doing this, we're checking for angry first. So if you go ahead and run this, you should be able to, I can make it bigger now. You should be able to create smiles, just like we had before. And then if you click on one and just hold down the mouse button, it should become angry. You can see he got angry because his eyes turned red. So if I hold down on this one, his eyes will come red. His eyes are red. You can also see that they're popping to the front. So he pops to the front and his eyes turn red. I will say that you can't really be angry with a smile like that. So let's do something about that smile as well. He does not look angry with a big smile like that. So let's go ahead and let's make another change. What I want to do is I want to, if we're angry, draw a straight line for the mouth. And if we're not angry, then we'll do the normal gradient that we did before. To draw a straight line, we could go through what we need to do with with core graphics, but I'll say if you want to draw a straight line, this code right here will do that. It'll set the line width. Here I set it to 10, and then it just moves to a point, adds a line to a point, and then it just draws it. Really, the only hard part here is figuring out where your code for the mouth starts. So if I look at this, I created a path. Which was fine. And then where my mouth actually starts is right here. So I add this path for the mouth. So what I want to do is I want to add this new code and all this old stuff for the mouth. So all the old stuff for the mouth can go inside this else branch. And so if it is angry, it should draw a line. And then if it's not angry, it should smile. And this is the same mouth stuff. So let's see if we can make this work. So let's put a couple smiles on here. And now if I click and hold on this middle guy, his eyes should go red, his face should go frowny. That is a good angry face. So now you can see that we've got a couple things. We've got a way to bring things to the front. We've also got a way to make an angry looking face. Cool. So kind of had a little fun there with the core graphics and the changes you can do. But really the point was to show you about gesture recognizers. But I couldn't help but sneak in a little bit of fun and a little bit more about core graphics. Also, you can make these things angry even when they're rotated and big. So if we make them rotated and really big and we hold down on him, you can see that he gets angry just like everybody else. So that's kind of neat. Cool, so those are some of the gesture recognizers. To show you a couple more, and also to make another point about gesture recognizers, we're going to add two more, but we're not going to add them to the smile view, we're going to add them to the super view. So what we're going to do is we're going to use a tap gesture recognizer. So if we were to go look at the gesture recognizers, this one is tap. Tap has a minimum number of taps required in order to call it. It's also a discrete instead of a continuous. So it'll just let you know. So it's a discrete gesture, which is one we have not yet done. And so we're going to handle it a little differently. It's not going to have the begin, changed, and ended. It's going to be a little bit simpler. So to make this happen, what we're going to do is we're going to work not in the smile.m, we're going to actually work in the view controller, and inside the view did load. You can see we set the background color to blue. Now we're going to do a couple other things. We're going to add these gesture recognizers. So the tap gesture recognizer has the same form. We say what action to call, so we're going to handle 3 taps. And for this gesture recognizer, we're going to say number of taps required is 3. I really like how Objective-C does things. They make their names so clear you don't even need documentation. I mean, the name of this property is number of taps required. You're not exactly going to go click on this and say, hey, number of taps required, what does that do? The description is basically the same as the name. So I grew to really like that. And with code completion, it works out really handy. So I add that one. Then I also add one for 4 taps. I set its number of required to 4. And it's going to call this function. Cool. Also, you can see if you look closely at how I did this code with memory management, I actually used one pointer, but then I have 2 different objects. So I made an object, I released it. I made an object and I released it. But you can see I only actually made 1 pointer. That's totally fine. The way I did this for memory management is totally fine. Let's go write 3 taps and 4 taps. So what I want 3 taps to do is I'd like for 3 taps to delete just the view that it's on. So I'll just say UI gesture recognizer callbacks. So for 3 taps, what I want to do is I want to remove the view that it's on. There's a couple ways to do this. The way that I chose to do it is I chose to use, there's a C function. There's a bunch of C functions for recs. One of them is rect contains point. So I say, does the rect aframe.view, so this is the views frame, does this rect contain this point? And the point that I got is from the gesture recognizer. Much like touches, gesture recognizers have locations. So I'm going to say location in view self.view, because I'm in the view controller now, so I say self.view. And if the touch was in there, then go ahead and remove it. So if I go ahead and run this guy, and I make a bunch of smiley faces, and then I triple click, so I'm going to triple click right here, so 1, 2, 3. You can see it destroyed anybody that was inside that region of death. If I triple click out here, 1, 2, 3, you can see it actually made a smile on the double click. 1, 2, 3. Oops, I wasn't fast enough. 1, 2, 3. So you can actually kill individual smiles if you want to this way. Not saying triple clicks is a really elegant use of your user interface, but it is neat that you can do it. The other thing that may or may not have surprised you is before, if we double click on a smile, it doesn't go through to the view controller, but a triple click, 1, 2, 3, gesture recognizers, the point I'm trying to make here is gesture recognizers look at all subviews. So even if it should have gotten picked off the responder chain, gesture recognizers don't respect the responder chain. You can see I clicked on them all and I somehow caused some sort of problem. Oh, I 4 tapped and I haven't written that function yet, so I crashed it. So let's go ahead and write 4 taps. With 4 taps, all I want to do is I just want to remove every single view. So it's actually simpler. I just go through all the subviews and I say remove them no matter what. So it's actually an easier function. So if I put a couple views up here and I quad click, so 1, 2, 3, 4, you can see it just clears the screen. 1, 2, 3, 4. Cool. So we've done a lot with this. We've added the ability to move them. We've added the ability to zoom in on them. We've added the ability to rotate them. We've also added the ability to make one angry, the ability to move them to the front, and then finally the ability to triple click to kill it, and then quadruple click to kill them all. So hopefully this gives you a pretty good introduction to gesture recognizers. They're really easy to use. We pretty much covered everything with them. And hopefully in this example you really learned a lot about core graphics as well. I hope you enjoyed this example. I thought it was a really good one. I think it's a good way to learn this stuff. Cool. We'll see you next time. We're going to start switching gears next time. We're going to start learning a little bit more about persistence. See you then.